Hi everyone, welcome to another episode of Together Talks, a series of conversations with researchers and industry leaders about AI, brought to you by Together AI. I'm Zhang, a co-founder and CTO of Together AI. Today we have incredible special guest, Scott Wu. Scott is widely regarded as one of the best American competitive programmers in history, having won 3 gold medals in IOI, and having achieved remarkable success from a young age. Scott co-founded the AI-driven social platform Lunchclub, and is now the CEO of Cognition AI. Scott, thank you so much for joining us today.
Thank you for having me. I'm excited to be here.
Let's start by talking about your journey, right?
Yeah.
Given your strong background in both mathematics and computing, how do you think your competitive experience have shaped your skills and mindset as a founder?
Yeah, I think I was always very, very competitive as a kid. My first math competition was actually in 2nd grade. I was 7 or 8 years old. I went to this local math competition. It was a competition for middle schoolers, actually. So I competed in 7th grade math. And then I remember this very vividly still. I went, and then I was like, I loved math and stuff, and did the competition, and then I didn't win a prize. Like, the 3rd place, 2nd place, 1st place, and then none of them were me. And then I was just really, I was just really upset about it, and then I trained a bunch, and then I came back the next year, and then I did it was Algebra 1 or something the next year, and then I won then. It was ever since then, it was always just, math competitions, programming competitions were kind of my whole life, honestly, as a kid. And yeah, I mean, what are the main things I carry over? Honestly, I think a lot. I think there's obviously some, the math itself and the computer science itself. There's a lot of kind of just the technical details that are obviously all kind of correlate. But I think even beyond that, just the willingness to be very brutally honest with yourself, I think is very important. The ability to just examine your own flaws and be ready to work on it. Obviously, a lot of the kind of the general things of working hard and figuring out how to really put your best into it and to go for success. But yeah.
Yeah, that's super cool. Yeah, so how do you think that experience kind of influence Cognition and Devin, right? Because I remember the first time I saw the Devin demo, I also remember it's really shocking experience, right? So I think there are actually 2 different parts. The first one is I'm kind of shocked by technology, right? So it's you can actually do that now. The second is really, even if I know the technology can actually achieve that, I wouldn't thought about just try that application, right? so what inspires you? What triggers you to actually even try that?
Yeah, I mean, so a lot of our team actually, our whole initial team was kind of, many of us knew each other for many, many years. Actually, a lot of us first met in these math and programming competitions. And, we wanted to work together. And a lot of us have all had our own journeys in AI, for the last 5 or 10 years. One of my co-founders, Steven, was very early at Scale AI. My other co-founder, Walden, was early at Cursor, and then also had messed around with a lot of his startup ideas as well. I personally built a company called Lunchclub, and the whole team was kind of like that, And yeah, I mean, I think we had a lot of ideas of what we wanted to do. I think code was obviously very, very exciting to us from the beginning. I mean, we all love coding, we're all engineers ourselves. But also, I mean, I think code is, I think, one of the most powerful direct applications of better reasoning and better logic, right, out there in the world. I think code is probably one of the main drivers of progress, honestly, in the world, in the last 50 years, call it, right? And so, so that was always really exciting. But I think more than that, I think to your point, we were really excited, I think, to kind of explore much deeper what it would look like to not just have a coding assistant, but actually, a more autonomous decision maker. I think one of the other big things about code is that it is honestly inherently a very agentic task. In theory, for example, you can have the whole code base and have an explanation of, all right, here's what I need you to do. And you just spit out a perfect diff, and it's just correct. But obviously, no human can do that, and at least today, no AI can do that either, right? And in practice, what coding is more like, you read this file, you read that file, you pull up the documentation, you run the code yourself, you test it out, you add some print statements, you debug, you pull up the front end, you do all these kind of like iterative things, and then you come out with a diff that hopefully builds what you want it to build, right? But like, yeah, I mean, I think naturally having agents that can do that was something that was really, really exciting to us from the beginning.
Yeah, so that's also, I think, why it's pretty shocking experience from the user perspective, right?
Yeah.
So I still remember that I can type in a single sentence, build this, and the whole thing start to plan, start to actually divide and conquer, start to decompose into different tasks, right? It's a really amazing experience. So you mentioned about this, like, the experience shifts from coding assistant, right, like CoPilot, right, to Devin, right, which is kind of this more agent type of framework. So how do you imagine, like, if in a couple years we look back, because they kind of occupy different extreme of the spectrum, right? So there is this like human as the main driver, right? So and the CoPilot is my assistant, and you have this Devin thing, right, where, yeah, pretty much it have a different interaction model, right?
Right.
So where do you think we will land in a couple years?
Well, I actually think they're quite complementary. And so, I think a lot of these products out there, like the CoPilot style products, like you're saying, I think are actually really great products, You're coding and you're implementing things and it gives you the suggestion and you can auto-complete, right? And kind of all the little tools, like that, are super, super useful and make people faster. I actually think it's, it's very complementary in the sense that I think for certain tasks that you want to handle yourself and you want to be, very specific about how you're going to implement it and do it, I think CoPilot and the kind of assistant products are the tool for you, right? Because it'll take place in your environment, in your IDE while you're building. Whereas I think the way I'd almost describe agents is more like tasks that you want to delegate entirely, right? And so maybe one way to put it is, CoPilot type tools make everyone a faster engineer. And agent tools make every engineer into almost an engineering manager. You have your own team of interns, and you can assign your interns tasks. And so, I think for quite some time, I think we'll have both of these actually.
Yeah, so I think that's an interesting perspective. So, like, one thought experiment that kind of really curious about how to think about it is, if you fast forward 5 years, how would you describe a daily life of a software engineer?
Yeah, I think it's going to change a lot. I mean, I think and by the way, I think it's always changed a lot. I think that is one thing that we often underrate. It wasn't that long ago that programming, was like punch cards, and you go and like fill out the right, and that was what programming was, right? And then somebody invented assembly, and assembly. When that happened, there was this question of like, well, what happens to all the programmers? And of course, the natural thing was, there's actually even more programmers, and now they write assembly and they can do way more things, right? And then we had, C, or there was COBOL or Fortran or whatever, and eventually now we have Python or things like that. We have frameworks and clouds, and I think I think it's interesting because I think the history of programming has kind of been like an exponential curve of programming getting more and more effective, maybe I'd put it, but also of there being more and more programmers, right? And so I think in the long run, what does a software engineering job look like? I think it's, I think even today, what makes someone like a really great engineer, if you say, wow, this person is a really amazing engineer, usually you don't mean that they type very fast. I mean, obviously that's nice too, and sometimes it's cool, but I think the biggest thing is like the ability to really, to solve problems, to break things down, to have really great intuition about what works and what doesn't work, to build things in a way that, is very like future ready and understand how things might change in the future, right? And I think all of those things are still going to be really important. And basically, I think that the engineers of the future will be more like, almost like these technical architect types, or halfway between a technical architect and even like a product manager, right? Where, you get a problem and you're just thinking about, how do I break down this problem? What exactly is what I want to build? What are all the details and the flows and the cases, and what is the solution that I want to build exactly? And once you can describe that, then it'll just be built for you, right?
Yeah, that's very cool. But how would the interaction works, right? For example, I can imagine that I have a problem, right? So and ask Devin, so
Yeah.
this is my problem, help me, right?
Yeah.
So it goes through this very interesting process. It has the planning process, right? And
Yeah.
then have a different subtask, every single subtask trying to do, right? So how do you think at some point, as an engineer, I should kind of inject my feedback into
Right.
Devin, right? Then we have this loop, right? And sometimes there may be another way that can solve the problem better, right?
Yeah.
So how would that work? Will that be a conversation that we are having with Devin, or will that be Devin ask, okay, I get stuck, right? What should I do, right? So how do you think that thing will evolve in the future?
Yeah, or eventually you'll just have it, Neuralink plugged in where you just think it and then Devin will build it for you. Yeah, I mean, I think like maybe the way what I'd say is I think it's going to be pretty different from anything that we've seen so far, and I do think in general with AI. I always love this quote where people were saying, like, the first intuition with AI is thinking it's going to make better movies, but I think the reality of what's going to happen is we're going to make something that's like a totally different experience that offers what movies today offer, right? And it's going to be different, it's going to be like way better and more capable, right? And I think the same is true in general. And so, I think the closest comparison today, I'd say, is kind of like having your own team of interns who can just do whatever you tell them. But of course, I think there are a lot of things about it that are going to be totally unique and kind of things that we haven't seen before at all. But yeah, I mean, I think at a high level, it does. I think it does basically look like that, like a very conversational nature where you can kind of, whether it's voice or typing or whatever, but like you can kind of just dictate, okay, we're going to have this page and it's going to look like this. And, if you click this button, it goes here, if you're building a front end, right? Or if you're building, figuring out how to architect stuff on the back end, you're going to say like, okay, I want my database to be this technology and I'm going to set it up with X and Y. And, here's how I want the tables to set up. And then kind of just be describing that out. And yeah, one of the cool things is that you're going to be able to dynamically make changes easily, right? And you can say, oh, wait, actually, let's change this up a little bit and let's do that, right? Or let's add this thing, and you'll just be able to say those things and have those be implemented, right? And so I think at a high level, it's kind of like, I think Devin, at least for for quite some time, Devin is not going to be the decider of what to build, And so I think that still rests firmly in human hands, right? And from there, a lot of it is just making it so that software engineering is as easy as it arguably should be.
So I think that's a very exciting future. So I really like this analogy about having this one person have this group of interns, right, who can actually help you. But if you look at the current kind of organizational structure, right, so there are people who are specialized in different things, right? So that's where the power of a team comes in. People are good at different things, right, specialized in different things. Do you think Devin will start to specialize? You have some type of Devin who can do this, some type of Devin who can do front end, right? So, and all do you think will be a big Devin that can pretty much do everything for you? And then you have this I
mean, I actually love thinking about this stuff because I think as you can imagine, we explore like a lot of these different ideas with like multiple agents and things like that. And similarly to the previous one, I actually think it's the kind of thing where our intuition obviously is like human organizations and how different humans interact with each other. But with agents, like a lot of these paradigms you don't have anymore. And so like one of the big things with humans is I'd say there's kind of this coupling between the action agent and the context, right? Where it's like one person knows one set of things and is acting kind of serially based off those things, and they can communicate with each other, right? Which is a paradigm that we could use, but I think within agents, there's a lot of things, the obvious things like if you're asking, hey, like, can you find where in the code base, is like, like I don't remember exactly what it's called, but I need the variable that, corresponds to this gradient or whatever, right? A human will go and click through different files, maybe go through and do some fuzzy search and stuff like that, right? But it's all serial, right? Whereas with an agent, you can kind of just spin up 10 different agents that are all acting and all, kind of searching in parallel to figure it out. And not only that, they can actually share the context with each other, right? And so it's kind of like, I think you will be able to do things where you have like a lot of parallel agents, maybe some with different capabilities, but they actually all share kind of underlying knowledge and context and, kind of are able to share learnings that way. Yeah, that's my sense, yeah.
So, and you think they will also share the same expertise?
So I think it's an interesting question. I would personally guess right now that they will share the same expertise. Obviously, you can imagine having targeted models for each one. I could see it either way, but if I had to guess, I'd probably guess the former. But I do think there are a lot of other kind of details that can change, right? So a very simple one is there are a lot of tasks that perhaps you can do more straightforwardly with just pure execution, where you don't need the most compute-intensive model, right? And there are some tasks that are kind of the really deep planning ones and seeing things very far in advance where you want the most intensive ones, right? And you can have a team of different agents where the agents are kind of there are different flavors of the agents, right? And there's a hierarchy where they're splitting up tasks like in the appropriate way and figuring out how to do that, right?
Yeah.
So
I think that's very interesting. So, I mean, at Together we are building this inference platform.
Yeah.
Right. So today I think there are more than 100 models out there.
Yeah.
We start to see how people are interacting with these models and how people think about which model to pick. So that's why I'm really curious about this, like whether the model going to essentially specialize, right? Because there are probably multiple. So I can see two different reasons that a model could benefit from kind of being specialized. The first one is economics, right? A smaller model can already do some tasks, right? So, and it doesn't make sense for you to have a very big model, do a very simple task. There's a whole economics optimization argument about specialization.
Yeah.
Another dimension could be you really need to be specialized to enable some capacity. That is, you are reaching kind of this level of accuracy or quality that's so high that a single model simply just cannot handle it. You have to specialize, you have to dedicate the whole attention of the model, right, on a specialized task for it to actually reach the capacity that you want. I'm kind of curious about how do you think about these two different dimensions?
Yeah, that's interesting. I mean, so the economic argument obviously I think makes a ton of sense. And I think in general, for sure, I do think, especially over time, just building up the kind of Pareto frontier, right, of different capabilities, where some things again will require the absolute most powerful reasoning or something, and you will need to pay more for those. But some things that are very kind of niche, just kind of knowledge recall or execution type things that can be done in less compute, I think will be done, with smaller models. Yeah, I mean, I think as far as the specialization thing, I mean, it's interesting. Yeah, I think it depends. I think it largely depends on, what happens with the shape of these transformer models, right? If it turns out that having a really big model that contains all the knowledge is actually able to kind of selectively pull out each of the different specification, the specific skills, or whether it makes sense to have specific ones. I honestly, I could see it either way. So
that's very cool. Yeah. So another question that we are very curious about is about open source models.
Yeah.
Right? So I think the Devin first release it based on closed model, right? The frontier models, and there's a lot of open model being released. The recent Llama 3.1, right? So especially the 400 billion parameter model one, right? So how do you see open model factor into the future of Devin?
Yeah, I mean, I think it's great, and I think open source models will continue to grow and to expand. I mean, I think my sense overall is I think first of all, I mean, I think there's just a ton of growth to come in AI. And there's a ton of use cases more, and tons more to unlock and tons more to productize and everything. But yeah, I mean, I also, on top of that, I think that I think that the existence of open source honestly does, promote a lot of this and make it easier to do a lot of this. And I think a couple of the biggest reasons right now, I think, to do open source, one are because of the economics, and two because of people who want the most kind of custom control over whatever post training, fine tuning, whatever inference time tricks or things like that they want to do. And so I think those will continue. But then I actually also think we were talking about a little bit about this earlier, but like I think as the level of all the models increases, I think there will be a lot of natural things where several models will suffice, right? And given that, of course, you would prefer to work with the open one, all else equal. And so, yeah.
Yeah. So, what would be your wish list for people who are building open models?
I mean, I think for us, I think I mean, I think the biggest thing for us, obviously, is logical reasoning. And I think that's kind of what underlies both the code, but also the decisions around code, that Devin makes. And so, we do a lot of work with this, and we also, work with a lot of others in the space on it. And I think I think both in open source and closed. I mean, I think I think we're right at the cusp of actually a pretty big wave of reasoning capabilities, which is super, super exciting. And so I think it's going to be a fun kind of next 6 months or so when we see the new models coming out. Yeah.
Yeah, it's amazing how fast the field is moving, right?
Yeah, it's been a fun. I mean, it's been a fun couple of years.
Yeah, we used to plan in the time scale. Oh, hopefully in 2 years we will have this. Now we say, oh, maybe in 6 months, something new will come in, right? So, like about the reasoning capacity. Yeah. So, what do you think is a fundamental blocker for open model to catch up? Is that we just need more data? Because like logical reasoning is something that, in principle, it could just generate a whole bunch of synthetic data to teach the model, oh, this is actually how to reason.
Yeah.
Or do you think there's something more fundamental than that?
I think there probably are still a lot of gains to be had from these synthetic techniques of just generating data, and especially the kind of data where you have clear, verifiable ground truth signal, right? And so, I think Google DeepMind recently announced the result where they were able to get an IMO silver medal, right? Training models specifically to reason with math and doing lean. And I think one of the big things about that is that you have this programmatic way to verify proofs. And that makes it way easier to generate a ton of data, to get the right feedback signals on what's working and not working. And I broadly think that, over the next few years, we'll pretty quickly get to the point where any fields that we have a good ground truth data label for and an abundant way to create more data, I think AI will generally be able to kind of get to like peak human capabilities or even above human capabilities on. And so, yeah, I think a lot of the work to come actually is, in things like that and figuring out, the right data loops, the right synthetic data and so on. At least for the time being. I think in the far future, there's obviously, I say far future when I'm talking about
6 months.
But yeah, I mean, I think there's a lot of interesting ideas on, how to build models that generalize better beyond data, which I think there is, more to explore there. But I do think we are going to get a lot of gains even just by setting up the right synthetic data loops and just getting these, targeting the right utility functions with these. Yeah. So
it's very cool you mentioned about the Google paper that
it's amazing.
Yeah. So given your background, you've been in so many IOI models.
Yeah.
How do you feel this language model or foundation model going to change? First one, like how young people start to see those competitions.
Yeah.
Right? If machine can win it, what's the point for human to do it? And second, I guess the other way, how can machine help human to actually reach the next level of this like kind of intellectual pursuit of knowledge?
We do actually have a lot of anecdotal, a lot of historical data on fields that end up, losing to AI and what happens. And I mean, chess is still great, Go's going strong, poker's going strong. A lot of these pursuits are obviously still, very, very deep and interesting for humans to explore, even if we limit it to the AIs. What I would say is, I think the other thing, obviously, beyond that is that, it's not just solving the math problems in a little competition. There's, lots more math out there to find, right? And simpler, there's lots more code out there to write. And so I think getting these from the point where, clearly in a very closed environment, we can figure out the right loops and iterate and solve that, but getting to a point where we can do kind of this more informal reasoning and solve, like a much broader set of problems. I think it's going to be really, really exciting. I mean, I think like math researchers, for example, I think for the next several years, probably, I think are going to be doing a lot of human plus machine, right? Where, you come up with some ideas of new directions or something, and then the AI will help you prove dilemmas, along the way, right? And it just makes your work much faster because, anything that's within an IMO problem of solvable, it gets solved.
That would be fascinating.
Yeah. or even, I mean, obviously it will continue to expand from there.
Yeah.
I don't know, I mean, I think it'll be cool. I think maybe one way to put it is, I don't think there are any Millennium Prize problems left that will be solved purely by humans. I think I think it's possible that some will be solved by a combination of human and AI. It's possible that some will be solved entirely by AI, but I'd be surprised at this point if there were any more that will be solved purely by humans.
Yeah, that makes sense. If everyone have this ability to solve gold medal level of questions, right, we can actually focus our energy on something even bigger.
Yeah, and selfishly also, I mean, one thing that was kind of funny about the model is, there are several categories of questions. Combinatorics was always my personal favorite, counting and probability and discrete math. And, the model was able to solve all the questions except the combinatorics questions. And so, at least for now, we can say that that combinatorics is the holy grail of the IMO, but I'm sure that will get solved in the next, 12 months or so. So we'll see.
It's super cool. Yeah. So I think this interaction between human and machine, I think, is super interesting, right? I think one question that in many people's mind is about guardrail, right? Because if you look at Devin, each of these agents, they actually can change a lot of things.
Yeah.
Right. So the moment it asked me about my API key, I was like, should I really get what should I do? Right. So how do you think about AI safety and guardrail, and how can we make sure we can have this productive and safe interaction with this very powerful tool?
Yeah, I think one of the nice things for us, honestly, is that it's not just a kind of guardrails question. It's actually a literal practical question for our customers, because obviously our customers, who use Devin and give Devin their code base and their access to particular keys or whatever it is that Devin needs, your Datadog logs or whatever. They want Devin to make responsible decisions with that as well, right? And so, I think the main thing I would say in general about this is, I think we are firmly in a regime right now where, making sure it's safer or more kind of well-contained. I think we actually do that by making it better at reasoning right now. Our biggest kind of like, we always worry about the times where Devin misinterprets or kind of makes a wrong decision or something like that. And so I think I really think it all comes back down to reasoning, honestly. Yeah, I think a lot of the reasoning with it and being able to kind of like think through the logic of it is often what will make sure that the AI is doing what it is asked to do and what it is intended to do.
Yeah, so I think that's a very interesting point that you seem to be saying the better the model become, in principle of like, the safer it could be.
Yeah.
Right. So and I think that definitely makes sense, right? So so I think that's also kind of coming to another kind of curiosity that I have is if you think about how human engineers are interacting with each other. I mean, there's the testing, there's code review, right? So I mean, even for human, we do not have everyone just like commit into the main branch of GitHub, right? And there's always a review process and testing process, right? So it's a really kind of many layers of safeguard, even for human to actually work together.
Yeah.
How do you think that process will change?
Yeah, I mean, I think, it's interesting. I'm not sure. I mean, at least today, for example, Devin will be in the company GitHub and will make PRs and everything, and humans will review those. Similarly, if humans make PRs, Devin can also review those. And so, I think kind of for now, I think piggybacking off the existing system obviously makes a lot of sense because that's what we're used to and that's what's kind of natural, especially at these capabilities. I think over time, one of the nice things that machines can do naturally is just kind of much broader testing and automation, right? And so I think having a lot of agents that are doing, like Devin will make the PR and do these things, but Devin will also test its own code. Maybe it'll pull up the front end itself and click around and make sure, right? And so it does this already, right? But you can kind of imagine a world where changes can be much more thoroughly vetted actually by AIs everywhere before they go to production or before they ship or things like that. What happens in the long term? Yeah, I mean, it's hard to say. I think we'll probably have some kind of review system for quite some time, if only because you want there to at least be more than one, I'll say entity, more than one either human or agent that kind of like signs off on a particular change. But yeah, you could certainly imagine a world where it gets to the point where the testing systems and the automation are all so clean that actually you can just, as soon as it's clear what the desired behavior is, like, things can just ship.
But together, our dream is to build up this infrastructure for foundation models, and we want to make that essentially full stack, right?
Yeah.
All the way from compute to the training stack to the inference to fine tuning, right? So, how do you think this agent type of workflow like Devin going to have impact on the infrastructure? If you have a wish list, like the top 3 problems that infra companies should work on.
Yeah, I mean, so there's a lot, and probably I can't say everything, but I actually think there will be a lot of interesting things to explore at both post-training and inference time, beyond, I think, what's kind of currently, there are a lot of standards of what you do at inference time, right? And a lot of standards of how you do fine-tuning, for example. But I think both of those are spaces that will grow quite a bit. One thing that's interesting about agents, honestly, is we see this feel this very directly, but for example, if you have a chatbot or something, you ask one question, the model gives one answer, and it's like the total number of tokens or total number of requests is roughly, in direct proportion to what the user puts in, right? Whereas, if you ask Devin, hey, I need you to build me a whole web app that does this, this, and that, and then set this up, and add a database as well, and Devin is making all of the decisions along the way. Devin might be working for a couple hours or something to build the entire project. And as you can imagine, it's also extremely compute intensive, and involves way more calls and just way more inference, way more, all of these things. One thing I actually do think is going to noticeably change is that ratio, roughly, of kind of like training time versus inference time. I think they're going to be way more expensive inference things in general as you go from kind of chatbot to full-fledged, decision makers. And so I think there are a few natural implications of that, but one thing that's big, I think, is a lot of this optimization that you guys do, and a lot of the work that you do around like serving inference effectively, making it very easy for people to work with this stuff, making it cheap for people, making it possible for people to do their own custom work, is only going to get more and more important over time, honestly.
Yeah, so I think it's very interesting you mentioned about this ratio between training and inference, right?
Yeah.
I guess there are 3 different things, right? There's pre-training, there's fine-tuning, and there's inference.
Yeah.
Right, so do you think there will be more fine-tuning, more inference in the future, or do you think it's just like we have this model there, we just like do a whole bunch of inference, we do so much inference that the cost of doing fine-tuning again doesn't really matter too much, or do you think it will be another kind of, another ratio that is, maybe every couple of days we fine-tune, we adapt, and then we do a whole bunch of inference for the next couple of days. How do you think that ratio is going to evolve?
Yeah, I mean, I think both post-training and inference are going to grow a lot. I mean, I think pre-training is going to grow as well, honestly, but my bet would be that post-training and inference grow more even. I think a couple of things. One is, as a whole, I think we will see kind of the next layer starting to be to really grow on top. And maybe the way I describe it is, I think today, if you think about the whole stack, right? I mean, there's hardware and there's chips and there's and it goes into the foundation models and so on. And often there are products again which are kind of more directly plugged into the foundation models. And I think there's going to be kind of a much bigger rise of the platform layer on top, where there are businesses and products that build applications on top of existing foundation models, that then serve their customers, but kind of through a much deeper process, right? And I think, I honestly think, that kind of leads to the explosion of both post-training and inference, right? I mean, these companies will typically have a lot of custom work that they'll want to do for their particular use case. And then also at inference time, they're going to be doing a lot more than just a direct chatbot, right? And so, yeah.
Cool. So another curiosity that we have, personally I have, is given all the development of AI and how the whole software engineering field is going to be changed in the next couple of years, what would be the advice you give to a young high school student who is really passionate about the field?
Yeah, you know, we've heard this question like a few times. For example, people would ask, like, you know, like, should I even study math and should I even study computer? Because I mean, it's all gonna be solved anyway. And my personal opinion is, I think it's a better time than ever actually to study, you know, the fundamentals of computer science and math and things like that. You know, I think partially because I think logical reasoning is obviously just like a really important kind of ground to have and work off of for almost anything, but also because maybe another way to put it is, you know, when you study computer science, you know, you're not just learning, you know, how to type certain things in a certain language. You know, you're not just learning like, you know, what TypeScript is like, and you know, how to like what a compiler is or whatever. You know, there's much more to it of actually understanding what computers are capable of and how to break down problems in a way that makes sense with computers, right? And often a lot of it is actually just clarity of thought that you have yourself. You know, algorithms as a whole field is even, you know, is less about the computer almost and more about, you know, you figuring out how exactly, you know, what is the best approach that's going to solve a given problem. And so, you know, I think that kind of training is going to be extremely useful, right? And, you know, we might not be typing JavaScript or, you know, whatever directly, C++, directly as much in the future, but I think the fundamentals of understanding how these problems work and how to break down things logically, and also like, you know, what a computer is fundamentally capable of or not capable of, are still going to be very important. Yeah.
How about competitive programming?
I think competitive programming, you know, it's, I mean, I think obviously, I think it will get solved quite soon. But no, I mean, I mean, I think it's both a lot of fun and also, you know, just a very rewarding experience, and you know, teaches a lot of these fundamentals. And so I think it'll do quite well. I think I mean, in fact, I think directly also, you know, I think a lot of people from these communities actually have gone on to do a lot of work in AI, and so there's at least some correlation there. But no, I mean, I think as a field, I'm sure it'll do quite well. And yeah.
Do you think the question we are going to ask in the future in competitive programming is going to change?
I imagine everyone's going to get a lot better. Is probably one thing, because people are going to have just like such great ways to train and learn and improve. And yeah, I mean, we'll probably have new algorithms. I mean, by the way, it's not just competitive programming, right? It's like all of theoretical computer science, right? I mean, I think we're going to make a lot of breakthroughs on algorithmic complexity and you know, kind of the core work there, because of the ability of AI to just really help us go faster. But yeah, I mean, I think it's the kind of thing where, yeah, I mean, a lot of the kind of the parameters may change, but I honestly think the fundamental piece will still kind of stay the same, of like, yeah, this problem solving, creativity, you know, being able to reason and use intuition and figure out, you know, what's going on in a particular scenario.
Yeah, thank you so much, Scott. It has been an incredible conversation, and thank you so much for sharing with us your thought and your journey. I'm really looking forward to see what's next in Cognition, yeah, and your career.
Of course, yeah. Thank you so much. I mean, it's great to be here. I'm really excited to see what happens next with Together.